I thank each one of you for watching my videos and encouraging me. Please like my videos and share with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We now discuss the solution of a problem from the question paper CSIR National Eligibility Test held in the month of December 2023. The question is from the section Linear Algebra and it is related to the properties of Jordan Canonical Form. The question is placed in part C, which is a multiple select question. There can be more than one answer and the question carries 4.75 marks. The question ID is 704076. Right, this question is suitable for all these examinations. Right, the given question is, suppose a 7 by 7 block diagonal complex matrix capital A has blocks. So the block size 1 consisting of 0, block size 1 consisting of 1, block size 2 consisting of 0, 1, 0, 0, and the block size 3 consisting of 2 pi I 1 0, 0 2 pi I 0, 0 0 2 pi I along the diagonal. Which of the following statements are true? We are given 4 options. Option 1, the characteristic polynomial of the matrix A is x cube into x minus 1 into x minus 2 pi I whole cube. Option 2, the minimal polynomial of A is x square into x minus 1 into x minus 2 pi I whole cube. Option 3, the dimensions of the eigenspaces for 0, 1, 2 pi I are 2, 1, 3 respectively. Option 4, the dimensions of the eigenspaces for 0, 1, 2 pi I are 2, 1, 2 respectively. Right. We now discuss the solution of the problem in detail. We are given a complex matrix capital A of order 7 that has the following blocks along the diagonal. So these are the blocks along the diagonal. Right. Now, therefore, the matrix A is a 7 by 7 matrix. Along the diagonal 0, that is block size 1, 0, block size 1, 1, along the diagonal, block size 2, 0, 1, 0, 0, along the diagonal, block size 3, that is 2 pi I 1, 0, 0, 2 pi I 0, 0, 0, 2 pi I, and zeros elsewhere. Right, that is the 7 by 7 matrix. Right, these are the blocks. The blocks are shown now. The block size 1 and the block size 1 again consisting of 1, block size 2 consisting of the matrix 2 by 2 matrix 0, 1, 0, 0, and at the end the block size 3 consisting of 3 by 3 matrix 2 pi I 1, 0, 0, 2 pi I 0, 0, 0, 2 pi I. Agreed. So I am sure it is clear to you. Right. We now take up the option 1. The characteristic polynomial of the matrix A is x cube into x minus 1 into x minus 2 pi I whole cube. Now, how do I calculate the characteristic polynomial of this block diagonal matrix? Right. So, what we do is the characteristic polynomial of A is the product of the characteristic polynomials of the blocks. Right. So, the characteristic polynomial of A is the product of the Cauchy polynomial of the blocks. Now for the block 0, the Cauchy polynomial is x minus 0, that is x. For the block consisting of 1, the Cauchy polynomial is x minus 1. And for the block size 2, 0, 1, 0, 0, for this the Cauchy polynomial is x square, that is lambda square. And lastly for this it is x minus 2 pi I whole cube. So that is equal to x minus 0 into x minus 1 into x minus 0 whole square into x minus 2 pi I whole cube. And that is x cube into x minus 1 into x minus 2 pi I whole cube, which is precisely the polynomial that is given in option 1. Therefore, option 1 is true. Option 1 is true. We continue in the next slide for the next options. Now you may, and what are the eigenvalues? X is equal to 0, x is equal to 1, x is equal to 2 pi I. And the eigenvalues of A are 0, 1, 2 pi I. And the algebraic multiplicity of the eigenvalue 0 is 3. It is repeated 3 times. The algebraic multiplicity of the eigenvalue 1 is 1 because it is repeated once. The algebraic multiplicity of lambda is equal to 2 pi I is 3 because it is repeated 3 times. Right, we continue in the next slide. Right, so that is our matrix, right? And the eigenvalues are 0, 1, 2 pi I, and their algebraic multiplicities are noted. Now we can write the Jordan canonical form of the matrix A, and we write here, and that is shown here. So this is the Jordan canonical form of A. So the Jordan block consisting of 0, Jordan block consisting of 1, the Jordan blocks of size 2 consisting of 0, 1, 0, 0, Jordan block. Now this block is split into 2 Jordan blocks. One Jordan block of size 2, 2 pi I 1, 0, 2 pi I, and the other is of size 1, 2 pi I. Agreed. So now it has 2 Jordan blocks corresponding to lambda is equal to 0 of sizes 1. This is of sizes 1. This is of sizes 2. One Jordan. So these are the Jordan blocks, right? And there is one Jordan block corresponding to lambda is equal to 1 of size 1. This is the size 1. And there are 2 Jordan blocks corresponding to lambda is equal to 2 pi I of sizes 2, this is the 2, of size 1. Agree? Is it clear? Right. Now we take up the option 2. The minimal polynomial of the matrix A is x square into x minus 1 into x minus 2 pi I whole cube. Now the exponent of x minus lambda corresponding to the eigenvalue lambda in the minimal polynomial of A is the order of the largest Jordan block corresponding to lambda. So corresponding to lambda is equal to 0, so it is x minus 0 that will be present in the minimal polynomial. And what is the exponent of that? It is the largest Jordan block corresponding to lambda. There are 2 Jordan blocks corresponding to lambda. The largest Jordan block corresponding to lambda is equal to 0 is 2. So therefore that will be x minus 0 square. And corresponding to 1, there is only one block, therefore x minus 1. Corresponding to 2 pi I, and the largest Jordan block is 2. Therefore you will have x minus 2 pi I whole square. So the minimal polynomial of A is given by x square, x minus 0 whole square, x minus 1 into x minus 2 pi I whole square. Right. So this is the one, but in the option it is given x square into x minus 1 into x minus 2 pi I whole cube. It's not whole cube, it is whole square. Therefore, the given statement in option 2 is false. The minimal polynomial is this only. Therefore, thus the option 2 is not true. The option 2 is not true. We continue in the next slide. Right, the Jordan canonical form is here, and the Jordan canonical form is here. Agreed, and it has two Jordan blocks corresponding to lambda is equal to 0 of sizes 1 and 2. One Jordan block corresponding to lambda is equal to 1 of size 1. Two Jordan blocks corresponding to lambda is equal to 2 pi I of sizes 2 and 1. This is already done in the last slide. We call on option 3 the dimensions of the eigenspace for 0, 1, 2 pi I are 2, 1, 3 respectively. Option 4 says the dimensions of the eigenspaces for 0, 1, 2 pi I are 2, 1, 2 respectively. We recall the dimension of the eigenspace corresponding to the eigenvalue lambda is equal to the geometric multiplicity of the eigenvalue lambda is given by the number of Jordan blocks in the Jordan canonical form corresponding to the eigenvalue lambda. Right. So lambda is equal to 0, then E lambda. So the dimensions of the eigenspace corresponding to lambda is equal to 0 is equal to the number of Jordan blocks corresponding to lambda is equal to 0. The number of Jordan blocks are 2. The dimension of the eigenspace for lambda is equal to 1 is the number of Jordan blocks corresponding to lambda is equal to 1. Algebraic multiplicity 1, therefore geometric multiplicity is also 1. The dimension of the eigenspace corresponding to lambda is equal to 2 pi I is the number of Jordan blocks corresponding to lambda is equal to 2 pi I, and there are 2 blocks. Therefore, the dimensions of the eigenspaces for 0, 1, 2 pi I are 2, 1, 2 respectively. Look at the option 4. Option 4 is precisely says this one, therefore option 4 is true. In the option 3, it is given 2, 1, 3, but the answer is 2, 1, 2, therefore option 3 is not true. Thus, option 3 is not true, option 4 is true. Summarizing all the options, the answer to this question is options 1 and 4. That is the detailed discussion of the solution of this problem from the section Linear Algebra, which is related to the properties of Jordan canonical forms. I have a suggestion to all our students. In the section Linear Algebra, it appears Jordan canonical form is very, very important. In some sense or other, there will be questions relating to Jordan canonical form in every question paper. My advice is you prepare a very good notes on Jordan canonical form, its properties, and so on and so forth. That will help you in the forthcoming examination. With these few words, I say, I am sure that you have understood the solution of this problem. Thank you for watching this video now. Please like my videos and share with your friends and colleagues. Please subscribe my channel if you have not already subscribed. I hope to meet you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.